STS presents complete package solutions for surface treatment of walls. Our new generation of paint removers are combined with the type of paint the surface requires. In Norway, we have developed a technique for the removal of old paint which has caused quite a stir. Here we will in detail go through the process of restoring buildings damaged by the improper use of paint. Today we know that all types of organic paint, such as acrylic, latex, plyolite, and other emulsion paints, must be removed from mineral-based surfaces, or else the exterior must be removed and replaced. The complete STS treatment package will be significant in economic terms, in addition to making our surroundings more appealing. Damage development. The old lime-based paints, which earlier worked fine and lasted for 20 or 30 years, had to give in to acid rain in the 1950s and 60s. The lime binder becomes sulfurated or turns into plaster. The lime-based paint becomes water-soluble and washes off in rain. At the same time, paint producers launched acrylic latex paints which enabled everyone to paint their facades with good results. For over 30 years, we have let ourselves be led to believe that a plastic or synthetic rubber film could work as paint on concrete walls for extended periods of time. Here is the result. Today we know that even a new film of this type is full of microscopic cracks created by tension in the film. Primarily due to ultraviolet radiation, additional serious material fatigue develops. The paint film loses its elasticity and cracks over the hairline cracks in the surface. At Tunsundjordet Housing Cooperative, paint had to be removed on 21,000 square meters of facade. The product used, in spite of a 15-year guarantee, is now like crisp toast and is totally unsuitable for painting. Other similar products, also delivered with extensive guarantees, are no longer available. Hundreds of thousands of square meters have been painted with these products and must in time be replaced. On Victoria Terrassa, soon to be restored, we can see a typical example of this damage. The last 2 times the building was repainted, acrylic latex and plyolite paint was used, respectively. Plyolite paint is based on styrene butadiene, a synthetic rubber. As you can see, we can remove broken down plaster with our bare hands. Acid rain breaks down the crystalline structure in the plaster. The sulfuration is quite advanced at this stage. Some areas are near the limit of what is salvageable. A complete removal of the old paint is necessary, with an addition of mineral binder to the plaster. The paint treatment must be such that the plaster can survive again. The situation at the Royal Palace is also serious. From a distance, the facade looks fine, but the damage is extensive. As with the university buildings on Karl Johansgata, this is the last chance to save the old plaster. All the plastic paints must first be removed, and thereafter that paint which satisfies the chemical requirements of the plaster must be applied. Chemically speaking, the old lime plaster needs a constant supply of carbon dioxide to maintain its strength. A dense plastic or synthetic rubber film on the surface takes away the plaster's conditions for survival. The lime plaster's hardening process is reversed. This part of the decomposition starts down deep, where plaster is attached to the brick. The plaster comes under attack from 2 fronts. The paint accelerates the decomposition. An entire culture of old buildings is disappearing, where beautiful old facades have to be knocked down and removed. Project Ila, 6,500 square meters, 70,000 square feet. We are now in Fuchsstadsgata in Ila, where one of our new STS paint removers is being used. The project is nearing completion. One man has removed all the paint on 6,500 square meters and avoided getting in the way of the plasterers and painters. Note the extensive cracking of paint and plaster. The weakened plastic film, with an entirely different thermal expansivity than the concrete wall, has had to give in and is cracked where there are cracks in the wall. During application of the paint remover, atomization is minimal. The application is very simple. The preferred method of rinsing off paint is to use a high-pressure washer with warm water. A hot water pressure washer with thermostatically controlled warm water from the machine's oil burner is quite reliable equipment today. Warm water greatly increases the rinsing capacity. Here we see the extensive cracking in the concrete wall. The paint remover should be applied in the afternoon so it can be allowed to work overnight. The rinsing technique is based on the characteristics of the new chemicals and has a large capacity. Project Bislett, 3,000 square meters, 32,300 square feet. In Bislett, the situation is also typical. The plastic film is cracked, thereby accelerating the breakdown of the facade. The application of chemicals is easily controllable. The chemicals' characteristics are such that if the paint layer is thick, a thick layer of paint remover can be applied without dripping. There are 4 different products, where 2 and 2 are closely related. These 4 products cover all the needs for facade use. On most projects, the products overlap each other, and it is often a matter of finding the most reasonable solution. Here we see how easily the paint is removed in large amounts. Again, the extensive cracking in the concrete wall is clearly visible. The repairing of damages is easily controlled. The finished product, with its original paint, enlivens the city. Project Tunssenjure, 21,000 square meters, 226,000 square feet. Tunssenjure Housing Cooperative consists of 17 apartment buildings. A thick, organic, plaster-like film, 2 to 3 millimeters thick in places, has to be removed. As you can see, after working overnight, the paint film has dissolved and is ready to be rinsed off. The seepage of moisture through cracks in the concrete wall has caused an extra large amount of crumbling along the sides of the cracks. The cracks become virtual craters when certain gable walls exposed to the elements are rinsed off. We find the same extensive cracking throughout the entire cooperative. The buildings are now in prime condition. The chemical and technical demands have been met, and there will be no future problems with the facades. Project Drammensveien, 3,000 square meters, 32,300 square feet. Project Drammensveien, with the necessary removal of several layers of paint. The cracks in the paint film become saturated when it rains. The strain on the concrete wall is not yet as extensive as we have seen earlier, but it is just a matter of time. Our paint removers soon give us a clean, perfect surface. This gives us the best opportunity to consider the character of the concrete wall and further treatment. Here again, we see how efficiently the system works. The cracking is revealed. Proper finishing. Paint. Keim Silikat is the only paint on the market today which, based on our experience and technical evaluations, satisfies our demands. One of the most important factors will be to fill and seal the extensive cracking which appears. Keim Contact with a filler of crushed minerals is available in different degrees of coarseness and will, through brushing in all directions, fill in and seal the cracks in the concrete wall. The finishing coat is Keim Granital, which is non-organically pigmented and will not fade. They have a standard selection of 270 colors to choose from. Project Mossbryggeri, AD 1830, 17 coats of paint removed. To us, Moss Brewery represents the most complicated removal yet of paint from concrete. After removing the paint, the administration building at the brewery was a patchwork quilt of plaster repairs done in connection with all earlier repainting. Now rinsed and painted with Keim. Project Akersgata, AD 1895, first Keim project in Norway. Akersgata 20, our oldest reference project, painted in 1895 with Keim, cleaned and touched up somewhat in 1983. The paintings are the originals from 1895. Project University, 10,000 square meters, 108,000 square feet. Almost 100 years later, the university buildings on Karl Johans gate were cleaned of plastic paint and painted with the exact same paint, Keim Purkrystallat. The plaster on the university buildings was saved in the nick of time. Thousands of square meters of fiberglass sheets which had been applied to the facade to bind the plaster were also removed. Today, the university buildings radiate in their original color and splendor. Project Diesengrenda, 38 row houses, the first STS project. The first extensive paint removal project was done in 1976 with the forerunner of STS-1 paint remover. 38 row houses with worn wood siding and flaking paint were saved from unnecessary residing and today look just as good as they did 15 years ago. The rest of the area, with a total of 100 row houses, was cleaned somewhat later. Project Nesodden, 3,000 square meters, 32,300 square feet. Removal of paint from wood with a large capacity. With minimal pressure and a water temperature of approximately 75 degrees Celsius, the removal is harmless. Today's new STS products remove plastic paints from oil-based paints or water-based stains from wood siding. As you can see, we get a clean surface, and the new treatment will be as on new siding. The finished surface can be as durable as that at Diesengrenna. Project Garden Hose and Scrubbing Brush. In Stavanger, a woman of over 60 removed the paint from her entire house using a garden hose and scrubbing brush. The chemicals were applied with a paintbrush. A perfect and clean surface ready for new treatment. Other projects. Hotel buildings with facades of plastered leka blocks. When the new conference hotel was built, it was requested that the leka blocks not be visible through the plaster and paint, as on the somewhat older hotel building. The conference hotel was painted with Keim Granital, which handles moisture well, and the leka blocks were not visible even during heavy downpours. After the first winter, the older hotel building got the full treatment. A perfect reference for proper moisture management. The old Nautical College, now Oslo Commercial College. The severely weathered plaster was reinforced with Keim Fixativ. This addition of liquid quartz greatly increases the strength of sulfurated plaster. The original appearance is maintained with 2 coats of a Keim translucent finish. In the interior, over 14,000 square meters were painted with an environmentally friendly and non-allergenic Keim paint. Prinsensgate 26, now a part of the Storting. The old paint was removed and it has been painted with Keim. The beautiful decorations have maintained their proper effect. The corner facade appears in its original splendor. Between the wooden row houses in Diesen, cleaned in 1976, and the 21,000 square meters of apartment buildings a stone's throw away, cleaned in 1990, lies 15 years of development. We consider ourselves leaders in this field. A number of projects have been completed on wood and on concrete. Nils Juelsgate, with its beautiful decorations, was saved for the future. The university buildings, where the removal of over 10,000 square meters of old plaster was avoided. We have now explained clearly